All right, so it says use the principle of superposition to find the voltage V in the circuit, and then find the power dissipated in the 10 ohm resistor. So the principle of superposition says, well, we want to, in definition, we want to remove a independent current source, find the voltage across this 10 ohm resistor. Then we're going to do another circuit analysis again, and we're going to remove the 110 volt source, and we're going to find the voltage across this 10 ohm resistor, and the sum of those two voltages across, whether either, well, when one of them is removed, then you have the other one there. The sum should be the voltage if we were to analyze the circuit as it is right now. So yeah, I'm gonna do that. So let's go ahead and I'm gonna take out the current source. So I'm gonna redraw the circuit. Oops. Okay, so 5 ohms, 10 ohms, 2 ohms, 12 ohms. So we're gonna have two loops here. Plus I1, I2. So our first equation would be 110 plus 5I1 plus 10 times I1 minus I2 equals 0. And then our second equation would be 10 times I2 minus I1 plus 2I2 plus 12 I2 equals 0. Okay, so I'm gonna plug this into the calculator. So we have this, and 0. Simplify this. I2 equals 0. I1 and I2. Right. So we have these values for both. And so I'm gonna call this V1. Right. We're gonna say this is V, and then we're gonna call the other one V2. And so we're gonna say V is equal to V1 plus V2. Right. Okay, so V1, oops. V1 is equal to, well, what's our values? So it would be 132. So it's I1 minus I2. 132 over 13 minus 55 over 13 times 10. So that would be I'm gonna round it off to 59.23 volts. So then we're gonna go ahead and do this again. This time without the voltage source. Okay, and I'm gonna make 3 loops this time, right? So this is 4 amps. Well, this we know is 4 amps. So this loop wouldn't really count. We have 2 loops. So I'm gonna call this I1, I2. So first would be 10 times I1 minus I2 plus 5 times I1 minus 4 equals 0, and then 2 would be 10 times I2 minus I1 plus 2, or well, 12, sorry. 12 I2 plus 2 times I2 minus 4 equals 0. Plug this back in again. This equation. Equals 0 minus I1 plus 12 times I2 plus 2 times I2 minus 4 equals 0. I1, I2. So we get these values, and we know that our V2, call this, is our I2 would be our V2 would be I2. So V2 is equal to I2 minus I1 times 10 ohm resistor, and it's 16 over 13 minus 28 over 13 times 10. That's negative 9.23 volts. And we know that V equals V1 plus V2. So we have 59.23 minus 9.23. So we have V equal to 50 volts exact. Since we know this, and we know the resistance, you play with the power equation, right? You know the voltage. So then the power dissipated across would be 50 squared over 10. And 50 squared is 2,500 over 10. So the power dissipated would be 250 watts. And this would be the solution to the problem.